Once upon a time, there was a student named Xander. He had EOC chemistry test due tomorrow, and he was studying for his test. But as we all know, chemistry isn't the easiest subject. But he had to ace this test, for if he didn't, he would have to go to summer school. I just don't get it. I just don't freaking get it. You know what? I don't even care. I didn't have anything planned for this summer vacation. No way. I was just take my ass and go to bed. Wake up, Xander. You must study. Oh my God, what the hell are you? The locals call me the Pig Wizard, and I am here to help you study for your final. For the very fate of your summer vacation depends on it. Thanks, but I don't think a lesson from a Pig Wizard is going to help me on my test. Well, you might as well listen, because you're going to be dreaming for a while. So, what exactly are you struggling with? Well, I understand the scientific method of steps in experiment, but I can't remember the different types of chemistry there are. Well, chemistry is the study of what matter is made up of and the changes it goes through. It would naturally split up into different groups. Do you remember there are 5 areas of study for chemistry? Yeah, but what the heck are they? Well, the 5 types of chemistry are organic chemistry, inorganic chemistry, biochemistry, analytical chemistry, and physical chemistry. Organic chemistry studies basically anything that contains carbon, and since most organisms contain carbon, that's why it's called organic chemistry. Inorganic chemistry is basically saying anything that does not contain carbon, like rocks and stuff like that. Biochemistry is the study of the processes that take place inside organisms, so like digestion in the human body. Analytical chemistry is the study of what things are comprised of, like how water is comprised of 2 hydrogen and 1 oxygen. And physical chemistry is the mechanism, rate, and energy transfer of when matter changes. So like how heat changes when ice turns to water. Oh. Yes. Is there really anything else that you need to know? Well, my teacher said I had to list 10 tools used in experiments and what they do. I know thermometer, graduated cylinder, beaker, and triple beam balance, but not much else. Well, there are tongs to hold up things like beakers when they're too hot. Wire brushes to clean glass that's too tight for things like sponges or rags. Test tubes to help for small reactions. Watch glasses for holding substances. And hot plates for heating things up. Ah, okay, thanks. Oh, well, I best be off. I have a client to attend to in about 5 minutes. Best of luck to you. Wait, I said sorry, my boy, but I have other business to attend to. Ask one of the locals. Maybe they can help you. Yeah, I bet they will. What was that?
Hello, stranger.
Please don't do
For the love of God, why does everyone do that? Hey, get back here. I'm not going to eat you.
You not?
No. I know I'm a lion, but I just came over because I heard you need help with something.
Well, yeah, I have an EFC chemistry test tomorrow and I need help studying.
Oh, I love chemistry. I can help you with anything, no problem. By the way, my name is Dorothy.
I'm Xander, and thanks.
Don't mention it. So, what do you need help with?
Well, an old Pig Wizard came by and taught me the 5 types of chemistry and the tools used, but I keep getting precision and accuracy confused. I have trouble remembering what matter is, too.
Well, accuracy is how close you are to the actual value of whatever you're measuring, and precision is how many times you get around the same area.
Still don't get it.
Imagine, it's like a bullseye. If you aim far from the bullseye, then you are not accurate. But if you keep getting it in that same area, you are precise. Same thing with the football.
Oh, so it's like accuracy is close to or on target, and precision is getting in the same spot or area over and over again.
Precisely.
Alright, still, what exactly does matter?
Matter is really anything that has mass and occupies space.
So, like me, you, buildings, trees, chickens, etc.
Yeah, that's simple. Coming! Sorry, I have to go. My mom's calling me for dinner. See you later. Hope you do well on your test.
Yeah, I still need help though.
Did I hear a call for assistance?
How convenient. 1, that was me. 2, who are you?
Who am I? Isn't of any importance, old chap. But what is important is that you require my assistance, and it would be my pleasure to help out.
Okay. Not even going to question this. Can you help me with units of measurement, conversions, sigfids, and scientific notation?
Of course, old chap. To start with, most of science uses the metric system of measurement, since they are multiples of 10. making it easy to convert SI units was just a revised version of the metric system. Length is in meters, mass is in grams, and volume is in liters. Prefixes determine how much bigger or smaller a unit is than the one that precedes it. Kilo means 1/1000th, so it is 1,000 times bigger.
Oh, okay. Then how do you convert?
I was just getting to that. When converting up, you divide the measurement you have by the measurement you want to get to. For example, go from 10 grams to kilograms. You take 10 and divide it by 1,000, since the prefix kilo means 1/1,000. So 1 gram would be 0.01 kilograms. To go down, you multiply the measurement to the measurement you want to get to. So, for example, if you wanted to go from 10 meters to millimeters, you would multiply 10 times 1,000, because the prefix milli means 1,000 times smaller. So you would get 10,000 millimeters.
Okay.
Significant figures follow 6 simple rules to make the numbers smaller. 1. All non-zeros are assumed to be significant. For example, if you have the number 2000, there is only one sig fig. All zeros between non-zeros are significant. Example, 101 would have 3 sig figs, since the 0 is between the two ones. Leftmost zeros that show up before non-zeros are not significant and act more as placeholders. They can be eliminated by putting the number into scientific notation, but we'll get into that later. Zeros that lie at the rightmost of a number and after a decimal are not significant. This number only has one sig fig. Zeros at the end of a number and to the left of decimal are significant, so this number would have 4 sig figs. The only time when sig figs are infinite is when counting or in exactly defined quantities, like 60 seconds equals 1 minute. Stay with me, my boy. Now, when adding or subtracting numbers, you round up to the same number of decimal places as the number in the equation that had the least amount of decimal places. When multiplying or dividing, you do the same thing, but with sig figs instead of decimals.
So the answer should have the right amount of decimal places or sig figs, depending on what kind of math you're doing?
Now, on to scientific notation. I assume that you have run into many gigantic numbers in your calculations, correct?
Yeah, and they suck.
Well, that's what scientific notation does. It shortens it. It has the coefficient, which is the whole number, and 2 numbers behind the decimal places, times a 10 to a certain power. The rule is that first digit has to be from 1 through 9, and continue to add numbers until the rest of the numbers are zeros. Then you count the number of places till you get to the end of the number, and then that number is the exponent to 10. Simple as that.
So, is that all then? I mean, seems kind of easy.
But it is. I'm sure you'll get it. Oh, look at the time. Sorry, old chap, but I have to go. Lots of other things I need to do. Hope I could be of some assistance. Also, wake up!
Oh, it was all just a dream. Thank God, I thought I'd finally gone crazy. Hey, I know more than I did last night. I studied, kind of. I'm gonna ace this test easy. Let's do this! 1 week later. I already know I passed this test easy, but I'll take a peek anyway. What? An F? But, the dream, the people, what the freak?
Well, he should have studied for real.
The end!